name is Timo Ahonen, and as David mentioned, I will be talking about visual inertial tracking today. The aim is to keep this at relatively high level, so make this an accessible tutorial. So in order to give you all an insight or high-level overview of how to do ego motion estimation or position estimation for AR devices. And just to get an idea of everyone's background, can we do a quick show of hands? So who here has worked with inertial sensors, accelerometers, or gyroscopes before? Okay, so some people are familiar. How about geometric computer vision, stereo, structure from motion? Okay, so seems that we have some people who already are expert or have some background in this area. So I come from a company called Meta. We are an augmented reality company making software and hardware for AR. We are based here in Silicon Valley in San Mateo, and we relatively recently started selling our most recent product. This is the Meta 2 augmented reality headset, and kind of the rest of the presentation will be in the context of how to make the tracking work for a device like this. And on the headset, this is an optical see-through AR headset, meaning that the graphics are projected onto the visor, and the user sees the world around them directly through the visor. So it's not camera-based AR as in some other or in phone AR products. This is optical see-through. And when it comes to tracking, it's similar, but there are a few details that will work differently for a see-through as opposed to camera-based AR. So today's presentation will be divided into 5 parts. First, I will give an overview of why we want to do pose tracking for AR and what that actually means. Then we will look into inertial sensors, how you could use those to compute the headset poses, and why that is actually not a feasible option alone. Next, we will have a quick or an introduction to Visual Slam. There is also another presentation on Visual Slam today, so I will probably run through, even though there are a bunch of slides, I will try run through those relatively fast. You will all have access to the slides afterwards, though, so feel free to go back to the slides or reach out to me for any details. Once we have covered the inertial and visual part, then we will talk about sensor fusion and how to combine the two modalities. And lastly, we'll talk about how to apply all of this to augmented reality.